Hello, everybody. My name is Mariam Iranfar, PhD in architecture. The title of my article is the development of aperture and residential building of Mediterranean climate for mitigation of carbon emission in Kyrenia, northern Cyprus, as a case study. Global warming, as we know, it is a significant threat for the countries which they are located beside the coastal areas, because each 10 centimeter rise in sea level will increase 10 millimeter square strips of the coastal area around the world. Carbon dioxide emission from the building increased by the using the fossil fuels or indirect using of fossil fuels through the electricity. The building sector consumes more than 40% of global energy and produces 24% of greenhouse gases. The current study tries to reduce the carbon dioxide emission in residential building in Kyrenia, northern Cyprus, with understanding the effect of the aperture, physical characteristic of the aperture on the energy consumption. Mediterranean region is one of the distinguished climate change hotspot and most responsible region for global warming. Aperture is defined in this case study as a transparent opening outer glazing area, and they are also important to adding aesthetic value to their building design. Kyrenia in northern Cyprus has selected as a region for the case study for two reasons, which is unique topographical character, which includes the coastal area, inland area, and mountainous area. The study hypothesizes that the understanding the physical characteristic of outer glazing areas with the respect of excellent view, mountain view, and sea view can develop the architectural environmental design criteria in Mediterranean climate. The aim of the study is to develop guidelines for aperture physical characteristic for lower carbon dioxide emission in the buildings, which assist the professional and government to legislate the new building rules. Two questions has been conducted in this research: how much the aperture physical characteristic in the residential building of Mediterranean climates affect building CO2 emission according to the limitation of the current study, and how much is proper to develop a model to calculate CO2 emission through resizing the glazing elements or the window wall ratio to reduce CO2 emission in residential building with excellent view as sea view and mountain view. The methodology case study samples selected in Kyrenia in northern Cyprus, 30 existing residential buildings with various topologies like detached houses, semi-detached houses, or apartment blocks in Kyrenia has with different topographic characteristic of Kyrenia, as such as coastal, inland, and mountainous areas has been selected. The height of the selected buildings is limited to 3 floors to neglect the different factors which is happening with the increasing of the height, like wind speed. The study will focus on the buildings with two main following orientation: northern orientation, sea view, and southern orientation, mountain view. This is the 30 case studies selected in different districts of Kyrenia, like Lapta, Sanca, Karagloglu, Karaman, and the observation method. Direct observation method for collecting data is including the classify the types and materials of the aperture, glazing area, and frames for the existing building in coastal area, inland area, and mountainous area of the Kyrenia. Determining window to wall ratio, WWR, in the residential building in Kyrenia. Identification of the building envelopes type for the selected samples. Including non-transparent elements like roofs, outer walls, and floors. This is the 5 different frames and glasses in the case study samples. The most common and prevalent was the first one. Design builder simulation software. The model was developed based on existing data collected during the different fieldwork for the selected sample buildings. The first step in the design builder simulation was to create the eventual model regarding the selected sample buildings with floor area 10 by 10 100 meters square. A single family unit is without basement and like cubic shape. The aim of the modeling is to simulate real condition according to initial indications. The climate condition of the sample building is simulated in the design builder. This is the one sample of eventual model for the study in summertime, in sea view, in morning, noon, and afternoon. This is the different tabs in design builder software location tab, which is include the location details, time zone, weather simulation, wind speed and direction, and site tab, which is belong to latitude, longitude, and height of the above the sea. How the location of the sample is defined by latitude, longitude, and elevation above the sea. And I found it from the topographical map of Kyrenia in Google, which is for the coastal area between 0 to 10, for the innerland 10 to 60, and for the higher mountain between 60 and 300. The weather simulation has been applied according to two main seasons, summer, July and August, and in the winter, January and February. This is the activity tab, which is explaining the factor. Activity factor for men is 1, for women is 0.85, for children 0.75, and the householding intensity is 20%. This is the sample of roof material and U-value calculation with design builder software. According the construction material were selected based on the direct observation of the selected sample buildings according to 8 of plans and available CAD files. This is the glazing tab, which is identify the glass elements of the building. The focus of the study is with the windows and doors, glass windows and doors. Different WWR and the dimension of glazing area on the eventual model, southern and northern walls. There are 3 different WWR applied in this research in order to understand the effects of the glazing size on CO2 emission in Kyrenia according to this climatic condition. This is the percentage in northern direction, southern direction, maximum WWR, average and standard, and the size of the windows. And type of glazing area on the eventual model. According to the observation for the window types in Kyrenia building, commonly one type of window glass prevailed, like double clear, and 3 different types have been suggested based on their cost and accessibility to apply in eventual model, to compare them in the simulation result to find the optimum CO2 emission through the windows in both sea view and mountain view. This is double clear, double gray, and triple clear glass. The electricity consumption is considered as the analysis and findings. The electricity consumption is considered as a major factor for estimating CO2 emission in the selected building samples. The majority of the sample buildings uses active heating and cooling system to heat and cool their units. Passive heating and cooling system are used less frequently in sample buildings. This is the annual carbon dioxide emission in coastal area, sea view and mountain views with different WWR and glass material through design builder simulation. This is the table with double clear glass, double gray, the triple gray in north and south, and this is the numbers for maximum WR, average WWR, and standard WWR. This is the same, but for the innerland region, and both region, coastal area and innerland area, have similar climatic characteristic and same solar radiation. During the simulation in design builder, ventilation and thermal bridge were not taken in consideration. The simulation focuses on the effect of window type, size and energy consumption and CO2 emission in selected sample buildings in Kyrenia region as a limitation of the study. This is this annual carbon dioxide emission in mountainous regions, sea and mountain view, with different WWR. This is the table for mountainous. And from the tables, this is the result analysis of sea view in coastal area buildings. The production of CO2 emission in summertime is more than wintertime. Maximum WWR lead to consume more energy than standard and average WWR. Cooling system consumes more energy than heating system by 2 times. Triple clear glazing is the more proper than other types, means double gray and double clear. Maximum WWR produce more than standard and average WWR. This is the analysis of mountain view in coastal area buildings. Energy consumption and CO2 emission in summertime is more. Maximum WWR producing more CO2 than standard and average WWR. Cooling system is consuming more energy by 3 times of heating system. Triple clear glazing is the most proper. But double gray only for summertime is proper also in this direction. Cooling load is more than heating load in the comparison of heating and cooling load. Analysis of sea view in mountain area buildings. CO2 emission in summertime is more than winter time. Also, maximum WWR produce more than standard WWR. Cooling system is consuming more energy than heating system by 2 times, and triple clear glazing is more proper than other types. Also, this is analysis of mountain view in mountainous area building. CO2 emission in summertime is more than but lower than other region. Maximum WWR is producing more than average and standard. Cooling system is consuming more energy than heating system by more than 3 times. Triple clear glazing is the most proper glazing than others. Cooling load in mountain view more than sea view by 14% when WWR is bigger with double clear glazing. A relationship between WWR value and carbon dioxide emission in Kyrenia. A linear regression analysis has applied to determine the relationship between CO2 emission and WWR value in different topographical area in Kyrenia, with consideration 3 different glazing types. The relationship will help to evaluate the CO2 emission per year according to the increase of WWR value and vice versa. The result shows very strong correlation coefficient, which is equal to 1. This is the table that we got it from the linear correlation. Conclusion. Studies show that there is high energy consumption and CO2 emissions to maintain comfort in the residential buildings in Kyrenia. The study suggested different materials to help in the mitigation of CO2 emission according to the building view and the location within the 3 areas, coastal, inland, and mountainous. The study suggested a mathematical model based on linear regression formulas to help the professional to evaluate CO2 emission through the WWR value in each area with different views. This is also showed that bigger WWR CO2 emission production in Kyrenia become more. CO2 emission in sea view is more than mountain view, and also CO2 emission in coastal and inland region is more than mountainous region, and sea view building in mountainous region can have bigger WWR by 33% compared to other to achieve the same CO2 emission. This is the references. Thank you.